Welcome to solverfy.
For the first part of this question, they are asking us to find the mass of the kernel in grams. And to do this, they give us some knowns. So our first known is the volume of the kernel is equal to 0.25 milliliters. And they tell us that the kernel has 1.6% H2O content by mass, and that the max percent is 75% of water in the kernel. They also tell us that the temperature is equal to 170 degrees Celsius. I'm just going to add 273 Kelvin to this to get 443 Kelvin, just in case we need to use it. They also tell us that the pressure is equal to 9 atmospheres. Alright, so we need to find the moles of water in the kernel to help us find the mass of the kernel. So we're going to be using the equation PV is equal to nRT. We're solving for the number of moles. So PV is equal to, or PV over RT. Alright, so this is the part A of this question. So we know that the volume of H2O in the kernel is equal to our volume of the kernel, which is 0.25 milliliters. And we're going to times this by 75% H2O over 100% of the kernel, because they tell us that the max volume of H2O in the kernel is 75%. So when we calculate this out, it's going to equal 0.1875 milliliters. Let's just change this into liters. So 1.875 times 10 to the negative 4 liters of water. So now let's get the moles of water. So our moles of H2O is going to be our atmospheric pressure. So 9 atm. We're going to times that by our number of moles of water, so 1.875 times 10 to the negative 4 liters. We're going to divide this by our R value. The R value I'm going to be using is 0.0821 liters atmosphere per mole Kelvin. And we're going to times that by our temperature, which is 443 Kelvin. Alright, so when we calculate this out, our moles of water is going to equal 4.639 times 10 to the negative 5th moles of H2O. So now that we have the moles of H2O, we can finally get our mass of the kernel. So the mass of the kernel, and this is going to be equal to our number of moles of H2O, so 4.639 times 10 to the negative 5th. And we're going to times this by the molar mass of water, which is 18.02 grams per mole. And then we're going to times this by 100% divided by 1.6%. They tell us that the mass of the water, or the content of water by mass, is 1.6%. So we're going to have to account for that. So our mass of the kernel, when we calculate this out, is going to equal 0.052 grams. So this is how we find the mass of our kernel. For the second part of this question, they are wanting us to find the volume in milliliters of our water vapor. And they give us another set of conditions that they would like us to find this at. So they tell us that the temperature for this reaction is going to be 25 degrees Celsius. So I'm just going to add 273 Kelvin to this. So this is going to be 298 Kelvin. And they tell us our pressure is equal to 1 atmosphere. Alright, so to find the volume of water, we already have our moles of water, so we can just use that. So PV is equal to nRT. We're solving for volume, so nRT over our pressure. So the volume of our water vapor is going to be the moles of water, so 4.639 times 10 to the negative fifth moles, times that by our R value, which is 0.0821 liters atmosphere per mole Kelvin. We're going to times that by our temperature, which is 298 Kelvin. And we're going to divide all of this by 1 atmosphere. Alright, so when we calculate this out, our volume of water vapor is going to be 0.00113 liters. And then they want this in milliliters, so we're just going to times it by 1,000 milliliters. So our volume in milliliters is going to be 1.13 milliliters. And this is the volume of the water vapor for the second part of this equation.